Welcome students, welcome to the chapter Chemical Bonding and Molecular Structure of class 11. And in this first part of this chapter, we will be discussing about the stability of atoms. We have seen in the last chapter about the periodic table, and in this part we are going to see or we are going to discuss about the stability of atoms. So as I said, we have seen in the last chapter about the periodic table and their classification. So in a periodic table, we have a total of 18 groups. As you can see here, there is 1, 2, 3 and so on, and it will goes until up to 18. അപ്പം മൊത്തം there are 18 groups. 18 group ആണുള്ളത്. And we know the first group is named as alkali metals. രണ്ടാമത്തെ ഗ്രൂപ്പ് സെക്കൻഡ് ഗ്രൂപ്പ് ഈസ് നെയിംഡ് ആസ് ആൽക്കലൈൻ എർത്ത് മെറ്റൽസ്. 3 മുതൽ 12 വരെ ഫ്രം 13 to 12 വി ഹാവ് ദി ഡി ബ്ലോക്ക് അല്ലെങ്കിൽ ട്രാൻസിഷൻ എലമെന്റ്സ്. ഡി ബ്ലോക്ക് ഓർ വി കോൾ ദം ആസ് ട്രാൻസിഷൻ എലമെന്റ്സ്. ദെൻ ഫ്രം 13 to 18 the 6 groups, 6 ഗ്രൂപ്പ് we call them as p block elements. Clear? Then we have to separate rows of elements that is placed below the periodic table, and they are the EF block elements. So we have ആദ്യത്തെ രണ്ട് ഗ്രൂപ്പ്, first 2 groups, they are S block elements. Then the last 6 groups from 13 to 18 അവരെന്ത് വിളിച്ച് they were called as P block elements, and the group from 3 to 12 we call it as D block, and the group that is placed at the bottom we call them as EF block elements. Okay, now since I already read the topic of this part that it is about the stability of atom, alle nammal already heading kandu, that was about the stability of atoms. And as you can see from this periodic table, what they have given are all atoms. ഈ പീരിയോഡിക് ടേബിളിൽ കാണിച്ചിരിക്കുന്നത് മുഴുവൻ atoms ആണ്. They are all atoms, isn't it? They are all atoms. And if you are trying to look around for these atoms in the environment or in the earth crust, നമുക്ക് ചുറ്റും നോക്കുകയാണെന്നുണ്ടെങ്കിൽ, if you are looking around us, which all are the atoms that you will see? ഈ ആറ്റത്തിൽ ഏത് ആറ്റത്തിനെയാണ് നമുക്ക് ചുറ്റും കാണാൻ പറ്റുക? Among these all the atoms, 118 atoms that is shown here, which atoms can you see around us and how you can see them, in what form? So let us try to figure out some of the atoms. കുറച്ച് atomsനെ നമുക്ക് we will make a list of certain, only very few atoms that we see around us, because we can see all the 100 until up to maybe 88 atoms can be seen. Others are, some of them are man-made, and some of them are not that stable. So the atoms that we see around us, so that's what we are going to see now. I have provided a list here, so you can see very few of them I have listed. So helium is the one type of atom I could see, argon another one, neon, krypton, xenon, then oxygen molecule. So here you can see this in atomic form, whereas here it is in molecular form. CO2 you can see around you. Iron, it is not in its atomic form, it's seen as a cluster. And H2 again not in its atomic form, it's a molecule. N2 again not in its atomic form, it's again is a molecule. H2O. So these are very few of them. You will I cannot list it here because there are many that you can see around you. So one thing what you might have noticed now, നിങ്ങൾ ശ്രദ്ധിച്ചിട്ടുള്ള കാര്യം, what you can see is that only certain atoms can exist in its atomic form. Atomic form-ൽ ആറ്റമായിട്ട് ചില ആറ്റങ്ങൾക്ക് മാത്രമേ നിൽക്കാൻ പറ്റുള്ളൂ. Only certain atoms can exist in its atomic form. Others exist in its molecular form. Which are they? So as you can see, I have separated them. I have listed those atoms in the top. You can see these are only the elements that can exist in their atomic form. These, so I can mark them separately. So what I have given here at the top, if I separate them, these are the only elements that can exist in their atomic form. Rest of them, you will never see oxygen as an atom under normal conditions, that is the conditions with which we can see around us. Clear? Then carbon dioxide, again Fe, though it is shown as an atom, it can exist only as cluster inside a metal. Same is the case with the gold. So the conclusion is that the elements that can be seen in their atomic form belongs to group 18. So all these elements belongs to group 18. So you can see helium, neon, argon, krypton, xenon, radon and oganesson. So all these things, radon and oganesson are comparatively unstable. So rest of them you can fish them from the atmosphere. Clear? അത് നമ്മൾ ചുറ്റും നമുക്ക് അനലൈസ് ചെയ്യാമെങ്കിൽ you can easily detect these noble gas elements in their atomic form. So let us read it out then. Among all the atoms in the periodic table, only noble gases എന്ന് പറഞ്ഞാൽ it belongs to group 18, are stable in their atomic form. Only noble gases are stable in their atomic form. അപ്പം അറ്റോമിക് ഫോമിൽ നിൽക്കാൻ പറ്റുന്നത് ആർക്ക് മാത്രമാണ്? നോബിൾ ഗ്യാസസ് ഓർ ഗ്രൂപ്പ് 18 എലമെന്റ്സ്. ഓൺലി ദേ ക്യാൻ എക്സിസ്റ്റ് ഇൻ ദെയർ അറ്റോമിക് ഫോം അണ്ടർ നോർമൽ കണ്ടീഷൻസ്. ക്ലിയർ? So this will arguably bring some questions. Certain scientists were thinking once when these periodic tables started to emerge, they were thinking why only these noble gases can exist in their atomic form, why atoms cannot. So if atoms cannot, you can see it from here, atoms can exist as compounds or metals or in clusters. Like they cannot exist as atoms, but they can exist in different forms. They exist because they are stable, isn't it? So that means the topic of today's topic is about the stability of atoms. So why noble gases have their stability, their atomic form has the stability, whereas rest of the elements, rest of the atoms that you see, their atomic form is not stable, but their compounds are stable. So based on this, we have few questions. Why are noble gases stable in their atomic form? So this is one thing that we need to find an answer for. ഒന്നാമത്തെ ചോദ്യം, ഇതിനുത്തരം നമുക്ക് കണ്ടുപിടിക്കണം. The second question is, why are the atoms in the periodic table other than noble gases not stable in their atomic form? So in the periodic table, it is not only noble gases, there are other atoms, isn't it? They are not stable. Why is it so? So this is the second question. And third question is, if they are not stable, what is the criteria for them to attain this stability? So we have seen that all the atoms other than noble gases can form compounds, isn't it? All the atoms other than noble gases can form compounds. If they can form compounds, that compounds are stable. So what is the criteria for those elements to attain stability in its compounds? അങ്ങനെ കോമ്പൗണ്ടിൽ നിൽക്കുമ്പം ആ ആറ്റംസിന് എങ്ങനെയാണ് സ്റ്റെബിലിറ്റി കിട്ടുന്നത്? So these were the questions that were asked from early 20th century, and many theories were put forward in order to explain the stability of noble gases and also explain the stability of compounds that we see around us. നമുക്ക് ചുറ്റും കാണുന്ന ആറ്റംസിൻ്റെയും കോമ്പൗണ്ട്സിൻ്റെയും സ്റ്റെബിലിറ്റി എക്സ്പ്ലെയിൻ ചെയ്യാനായിട്ട് there were lot of theories put forward from the beginning of 20th century. So let us see what were they. So attempts to answer the questions related to the stability of atoms has resulted in the formulation of various theories. So what you can see is a list of 4 theories. These theories, as the order suggests, the first theory came forward to explain this was named as Kossel-Lewis approach. So the first theory or the first attempt made to answer these questions, those questions that we saw in the previous slide, തൊട്ട് മുമ്പ് കണ്ട സ്ലൈഡിലുള്ള questions answer ചെയ്യാനായിട്ട് there were many theories that put forward, and the first one to do that was Kossel-Lewis approach. Following Kossel-Lewis approach, so during when the Kossel-Lewis approach came, there were few limitations, and in order to explain or in order to overcome the limitations in Kossel-Lewis approach, it was the second theory that was put forward. So Kossel-Lewis approach is sometimes called as KL approach. To overcome the limitations in this approach, second theory, which is called as valence shell electron pair repulsion theory, in short we call it as VSEPR theory. So the name itself is quite long and is a phrase which explains what is this theory about. So what is the name? Valence shell. So it's about the valence shell electron pair. So it's about the electron pair in the valence shell and their repulsion of electron pair in the valence shell. So this phrase itself is showing what is this theory, what this theory is about. Clear? So this is called VSEPR, and again VSEPR had many limitations. In order to overcome, the next two theories came, that is VB theory and molecular orbital theory. So the molecular orbital theory is the final theory that quite satisfactorily explained many aspects of the compounds as well as the stability of atoms and molecules. Clear? So these were the various theories that were put forward in order to explain our topic of today today's part is the stability of atoms. So they tried to explain the stability of not only just atoms but also molecules. So in this chapter we will see all these theories one by one. Though Kossel-Lewis approach had many limitations, it formed the basis, and from this basis further theories were developed. Clear? So from KL approach, then the valence theory took a leap from this first theory, and the later theories also were taking advantage of the knowledge put forward by these theories. Okay, so in this chapter we will see in detail about all these theories. Thank you.